All right, this video is going to address quadratic functions and models. It's meant as a video for sort of a review for precalc students, but again, it would be a quick review or a quick intro maybe for anybody else. Basically, four major things that we want when we're trying to graph a quadratic function. Again, you're always welcome to just plug random points in, make a random table, and connect the dots. And we should end up with our parabola, right? Our quadratic equations, quadratic functions end up being a parabola. But there are some helpful and easy to find pieces, such as those four on the screen right now, the y-intercept, the x-intercepts, and then of course the axis of symmetry and the vertex, right? So major parts to a quadratic function. So notice up top here, we just have an example function, and I've got the expanded form of it here, 2x squared plus 12x plus 1. And what we want to be able to do is find these four pieces. Again, one of those easiest points to find is that y-intercept. The y-intercept of any function is always where x equals 0. So what I would really want to find is f of 0 right now. So I plug 0 in for x, plug it in for both x's over here at the right, x squared being 0, x being 0. Those first two terms, if we work out the multiplication and add them up, are going to be 0. Plus 1 means we end up with 1 down there, and our y-intercept is 0, 1. Again, that c value, right, when we're in expanded form, we sometimes call this a, right, and b and c. That c value will end up being our y-intercept. Now, in addition to that, the x-intercepts are also usually very helpful to find. However, the x-intercepts often take a little bit more work. Again, x-intercepts assumes that y equals 0, or oftentimes we would say that f of x equals 0, which means that I'm going to set my equation equal to 0, right, down here at the bottom. So 0 equals 2x squared plus 12x plus 1. And again, now I have to decide on a method for solving. Again, we could try to use square roots, but hey, we have that middle term, so probably not a great idea. Factoring wouldn't be terrible, although we've got a 2 in front, which might make that a little more difficult. Which means quadratic formula is kind of my next go-to. You could complete the square. If you're a big fan of completing the square, it wouldn't be a bad idea. But again, I would jump to that quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Again, taking advantage of a and b and c up here from our equation. If we pop those into the calculator, again, if we're looking to graph, I'm not really looking for exact value answers. So I would just find that discriminant, make it a little easier to type in the calculator, find that number underneath the root. And since 136 is not a nice square root, toss that whole thing into the calculator, and we should get negative 0.085, or the point, negative 0.085 comma 0, and negative 5.915. Again, negative 5.915 comma 0, right? If we wrote them as coordinates, like I had done with the y-intercept up top here. Now, once we have the x-intercepts and we have the y-intercept, we could start thinking about the graph a little bit. Again, it wouldn't be a bad idea to remember that we just found two x-intercepts, one a little to the left of the origin, one a little farther out. We got our y-intercept of 0, 1 up here. And if I actually drew my parabola then, knowing that with a positive a value, right, since a was greater than 0, that positive a value, we're opening upwards. It means I hit all those points. We get that nice parabola there. Now mine doesn't look perfectly symmetrical, but remember that every quadratic, every parabola has an axis of symmetry. And again, that would be the line if we drew it right down the middle of our parabola, right, that we would get equal points, right, or points symmetric to, equidistant from that vertical line. Easiest way to find that would be just take our x-intercepts and average them. We just want to find the middle. So we could add those two numbers up that we just found and divide by 2. In which case, you'll also recognize, again, thinking back to our larger formula here, that just means we'd be adding the top of the fraction, and we would have a positive square root and a negative square root that would be alike, and basically we end up with the formula, if you may remember the shortcut, negative b all over 2a. If you think about that common denominator and sort of averaging them together and dividing out by 2, basically we get a nice shortcut there, negative b over 2a, the quadratic formula without, right, that square root portion in it. Well, in that case, we can toss in b being 12 and a being 2. Negative 12 over 4 then is negative 3. And the equation, remember it's a vertical line, right? A vertical line on our graph over here. The equation would be x equals negative 3. And then finally, we'd want to know what the vertex is. Again, what's that point at the very bottom down here, right? that point, that minimum point as we would call it, local minimum, what would that point be? Well, the nice part is the vertex is always on the axis of symmetry. So if we take a second, we can plug -3 in for x in our vertex, which means it comes down to just calculating the point. I would throw -3 into my equation, do the calculating, right? Put it into my calculator or do the calculating myself, and we will find out that we get -17, and that point's way down here. Again, a little misproportioned on my graph, but simple sketch. -3, -17 would be my vertex. Again, I hope that provides you just a quick and simple way to kind of find those parts. If you have any questions, make sure you talk to your teacher. Otherwise, if you're looking for other models of quadratics, don't forget this is just the first of 3 different videos. Make sure you watch the other 2 talking about vertex, or what's sometimes called standard form, and intercept form, or what's often called the factored form. Have a great day.